Welcome to our online lesson. We are Robertson View Academy and we offer both physical and online lessons. And for you watching this video, you can just subscribe to the video and like so that every time when I post a video, you can be notified. Okay. Now, we are looking at variations. Okay. Now, when we talk about the word variation, it comes from the word vary, which means difference. However, there are three types of variations which you are going to come across, which includes direct inversely variation and direct variation and also a joint variation. So to understand variations, let's say we have, let me give an example of a statement which can read as, let's say, given that y varies direct as x, okay? Given that y, it varies direct as x. Are we together? This is direct variation. Hence, we just say y is equivalent to, after turning this symbol for vary to equals, always put k for constant. Yes, constant variation, then you have your x there. But if they had said, given that y varies inversely, so y varies inversely as x, are we together? Then that would be y is equivalent to, where there's 1, we'll put k over what? Over x. Then there's joint. Are we together? Joint variation, which says maybe we can have something like, given that y, okay, varies direct as x, okay, and inversely as z square. Okay, so this is how what you need to understand on making the formulas. Here the formula was given already. We say it is given that T is equivalent to kV squared, where K is the constant variation. Hence, that was just a direct variation. So with a direct variation, we're going to say, the question says, find the value of K, which is the constant variation in this case. So to find the value of K, we'll say, okay, since T is equivalent to kV squared, what are we going to do now? We're going to start just replacing, because we're looking for K. So when V was 1, okay, T was 4. When V was B, T was 36. When V was 5, T was A. So we're going to use this box in here because we have the variables on both. What is T? T is 4. We'll replace 4 here, is equivalent to, what is K? K we don't know, it's 1 we're looking for, so it will be K multiplied by, what is V? V is 1, but we have a square. So that will just be 4 is equivalent to, what's 1 square? 2 will still be 1. 1 times K, that will just be K. Okay, K is equivalent to that one. Or others would say we have 1K, then you divide both sides by what? By K, by 1 by 1. But there you just have K as equivalent to 4. Hence, this is our inverse. Our constant variation. Okay, we look at B, which says find the value of A. To determine the value of A, which is our B now, we're just going to say the value of A being represented here. We've seen where A is. When T was A, V was 5. So we're going to say T is equivalent to KV squared. What's T? T is A, is equivalent to, so T in here is A, so we replace with A, is equivalent to, what's the constant variation, which is a 4, multiplied by, what's our V? Our V in here, it's a 5, so it will be a 5 square. Hence, A is equivalent to a 4 by 5 squared, giving us a 25. Hence, A was just 100. Okay, we look at C of our question. Now C says find the values, not value, but values of B. So remember, T is equivalent to KV square. So what's our T in here? First of all, our T is 36. Is equivalent to, what's our K? K is 4 by, what's our V? Our V is B squared. Okay, so here we can say, here we divide by 4 and here we divide by 4. This and this, we just remain with B squared is equivalent to this into this one, giving us 9. Hence we introduce square roots on both sides. Okay, hence B was just equivalent to a -9 or +9. That is why they said find the values, because they know to say once we introduce the square root, an answer can be just a negative or what, or positive. Okay, negative or positive what, 9. You see, these were the solutions.